Hello folks, and welcome to Leetcode, where we talk about algorithms and different data structures. Today we're going to look at one of the most popular problems at Leetcode, which is called toSum. Here we are given an input array of integers and some target, also an integer, and we want to find the two values in this input array that sum to that given integer here. And our task is to return the indices, and we are guaranteed that we would only have exactly one solution. So we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions. We are given an example right here. So our list includes those numbers as 2, 7, 11, and 15. So the index of 2 is 0. Then we've got 1, 2, and 3. Our target is 9. So we can see that our 0 and the first element are 2 and 7. They will give us the target. And we will return 0 and 1 because this is the indices of 2 and 7. So if we talk about how to get the solution, the most intuitive way to solve this problem is, of course, just checking every combination of two values and see if they can sum up to our target. So, for example, we can start at 2, right? And we check every combination that we can make, including 2. So we scan through entire array and check if any of those numbers added to 2 will give us the target. The most intuitive way to solve this problem is basically just check every combination of two values and see if they can sum up to our target. So if we start at number 2 here, right, and we go through our array and we check 2 and 7, if they give us target 9, they actually give. So we'll basically stop checking here and we will return 0 and 1 because these are the indices of the elements that give us our target. But here in number 1 we got lucky. But let's check example number 2, right? And our array is 3, 2, and 4, and the target is 6. So if we start at 3 and we go through the elements in the array, we sum 3 and 2, the first two elements. Do they give us the target? Well, they don't. Then we check 3 and 4. Do they give us the target? No, they don't. So we move to the next element, in this case 2. And then we check the rest of them, like 2 and 4. Do they give us the target? Yeah, finally, yes. This brute-force approach can be rather efficient, like if you got lucky, as in example 1, but basically it's not the best way to solve this problem. So let's move to how we can do it more efficiently. And we want to find another algorithm because when using brute force, we are going through sometimes the entire array of lengths, and in worst case scenario, we are going to do it n times for each number. And that means that overall, like the worst case scenario, time complexity will be O of n squared. So we have to do it better. And the thing that is very important for us in our search is that when we start our search for the second element, we actually need to find the difference between our target and the first element that we are looking at. So if we start, for example, at 3, 6 minus 3 is going to be 3. And when we go through our array, we need to find 3. We need to check if number 3 exists. So the data structure that is going to help us in our algorithm is going to be HashMap, because we are going to create a hash map of every integer that we have in our array, so we can instantly check if it exists in our hash map. And we are going to be mapping each integer in the array to the indices. For example, we are going to have 3, we are going to have 2 and 4, and the indices as values 0, 1, and 2 here. As you can see, we could actually add every integer and their indices into our hash map even before we start iterating through it. But there is a bit easier way to do that. We can start with an empty hash map. So let's delete it and see how it works with an empty hash map. And we move to our next element, which is 2, and we check if the difference between our target and number 2, which is 4, is in our hash map. Like, do I see it here? No, I see only 3. So what I do, the same as I did before. I put my next element, integer 2, as the key to my hash map, and I put it index here. And I do the same work for the next element, which is 4, and I check if the difference between 6 and 4, which is 2, is in my hash map. And it actually is. That is my key, the 2, and its index. So now I know that it exists, and I know its index, and I know the index of number 4, so I can return 1 and 2, which are the indices of element 2 and 4. So why I like this algorithm is that with this algorithm we don't have to initialize our hash map, so it can initially be actually empty, right? And we can just iterate through our initial array only once. So it can be solved in one pass. So our time complexity is going to be only big O of n, because in worst case scenario we are going to go to the end of, almost the end of our array. Yeah, we do use extra memory because we have our hash map, so it isn't free. Memory complexity is also going to be O of n, because we could potentially add every value to the hash map. And now let's get to the code, shall we? And we'll start our code with initializing our hash map, as we've decided that we are going to use this data structure to look for the elements. We're going to need several variables, and our first one will be index, as we are going to iterate through all the elements of our array. So that will be our first variable that we'll need, and we'll start at 0, obviously. One more variable that we'll need is the current number, of course, and we will also need the second number, because we'll need 2 indices, right? And our second number, and if you remember the trick that we were using in our algorithm, should be our target minus the current number. And we need them to be the sums so that we can solve it in one go, which is important. And now we are going to look in our hash map and check if it contains our second number. And if it does, and we are lucky, we are just going to get the index of our second number, as we already know the index of our first number, of our current number, and we are going to return those indices, and that'll give us our answer. But if our hash map doesn't have our second number, we will have to continue our search. But first, we will have to put this current number that we were working with into the hash map. So our current number, the key, and its index, the value. And we'll continue our search. We will have to use return null just for the syntax sake, but as you remember, in our task, we've got the condition that we would have exactly one solution, so it's just for the syntax sake. So now let's talk about time complexity one more time. As you can see, the time complexity is big O of n because we go through the entire array, but we do it only once. We do traverse the list containing n elements, but we do it only once. So, good news. And if we talk about the space complexity, that also is going to cost us big O of n because we introduce HashMap, and in our HashMap we can store, in worst case scenario, the whole array. And we are going to run our code to check if it works. Okay, we've got a slight syntax error, and you can see it's in line 7. Oh yeah, let's correct it. Let's put contains key and check it again. And now it works, and we've got the runtime, and it's very efficient. And we do have slight memory usage, but it's okay. It works. So we've solved the problem. Thanks for watching, and see you in the next videos.